We thought that she was an HR. Hey everyone, please take your seats. Oh, well, it was fast. You just become amazingly quiet. Just a quick announcement. If you're the owner of a green Tesla, you're blocking the garage downstairs, so please go ahead and move your car. The owner of a green Tesla? No? No one here? Ah, it's you. Of course it's you, yeah. Welcome to ReactNYC. Woo! Yeah, let's get started. So first, everyone's familiar with our Twitter handle? If not, please spread the word. We're trying to hit how many followers? 20,000 followers by the end of 2018. Sounds reasonable? Oh, wait a second. Oh. Feel free to take pictures, to post it, make some noise. Let everyone know that this is the best meetup in the city. All right. Oh, what's my Twitter is doing here? Oh, yeah. I need 5 more followers to hit 2,000 followers. So if I hit 2,000 followers during this evening, I'm going to do something very special at the anniversary. Promise you. If you know me, you know that I'm a man of his promise. So, yeah. Yep. Our YouTube channel. Are we broadcasting live right now? How many people? Excluding my 8? Oh, that's good. All right. So if you're not familiar with our YouTube, this is this guy. This is Roman. All right. Give him. Make some noise for Roman. He's responsible for our excellent live streaming videos. Visit our channel, please. Thank you. If you want to speak, if you want to give a talk, all right, but you're not sure how to do it, maybe you need some help, please contact us. Contact me, talk with me, with Roman, with Ilya, with Mena. Please raise your hand, all right? We can help you get on with something. This is a community event. We like to see new faces, all right? Sounds good? Go ahead and do it. Our next meetups on October 25 and November 8. All right. Does anyone already knows what those tokens are all about? Those strange names? Raise your hand. Who knows? No one? If you find out what is this token, you'll get nothing, but we'll mention you by the end of this event. All right. Yeah. If you're not familiar with our community-oriented masterclass workshop, so we've got another one. It's on meetup.com under ReactNYC. This one is going to be dedicated to clean architecture. It's going to be very interesting. So Monday, October 15, if you find it relevant for you, come. It's going to be fun. Next, React Clinic. Do you have health insurance? Who's covered? Anyway, react.clinic, that's the domain. Get in, make an appointment, and you can get free consulting about your React app. So I think that's the best offer I can make. All right. What next? Yeah, reactnext.com. Where's the logo?
Another space, I think?
Yeah. Woo, yeah. ReactNext.com, an international React conference in Tel Aviv. If you want to check it out, we've got a discount for you. So hit the website, check it out. Next, we want to say what? We want to say big thank you to Conductor, our host today. Where's the person from Conductor? Yeah. Woo! Yeah, come. But before, please, can you put your hand on the Redux and swear to use Redux from now until the end of your, thank you. So this is yours. Enjoy. Comes nice and worse.
Hey guys, I'll make this short and sweet. Thank you so much for coming. We're very happy and proud to host this meetup because the ReactNYC group is really awesome. Especially their video production is like amazing, and the attendance is always really great, so it's really cool to see everybody. And that's about it. I guess at this point I'm supposed to mention that like we're super awesome and we're hiring, but I feel like it's always a little dirty when the host says that. But FYI, we're super awesome and we're hiring. Thanks.
I think this is the only place where they still serve this cucumber water. So if you ever want to feel like you're drinking straight from the, I can't say it. All right, check it out. Cucumber water. You can, okay. I'll stop it right here. Last, before we get started, a big thanks to you. Because of you. Yeah, no, I'm not going to get any sentimental. We've got a great evening. We've got great talks. We've got Sean. We've got Rob. We've got Sergeant JSX, our special guest, our traditional quiz, and a lot of no surprises. So another last round of applause to you guys for making this happen. And Sean. Yeah, please welcome our superstar, Sean.
All right,
Go ahead. Yeah. You okay?
I hope the mic is on. Do you take the mic on?
Yeah.
Does this work? Testing. Okay. Testing. Whoa. All right. Got two mics. Okay. We good? Can I reconnect? I'll take this out. What just happened? Yeah, it was there and then it wasn't.
Oh, that's not a problem. You need to do it like this, like that.
There is a problem with
And I think your adapter is
bad.
yeah, it's bad. You got it someone? You need your laptop? Use another laptop?
I can use someone else's laptop.
Right.
You want to use mine?
Yeah.
Alright, yeah.
Sorry about this.
Just the adapter. Don't you have like a... You need a MacBook Pro. What's wrong with you?
You think we'd be good at tech?
It's not like that.
Yeah.
Just need slides.com. Oh,
Yeah, no,
yeah.
I see it.
Yeah. Okay. All right.
Oh, wait.
I need a new laptop.
Keyboard and stuff. Here, like, I need to quit some
Keyboard
things,
would be nice.
Because otherwise, the keyboard's going to be all remapped and shit. So, I hope there's nothing remapped. There might be things remapped.
All right.
But, like, probably.
I'm just clicking. Yeah, I don't have to type that much. All right. Let's see what's going on here. All right. Okay. Can I play this? Cool. Yeah. Okay. Hi everyone. Thanks for coming to this meetup. And I barely made it here myself. I just came in from Boston, where we just had React Boston, and it was a really, really good meetup and conference. But you're not here for that. You're here for GATSBY, and GATSBY is a React framework. I confess to having a little bit of clickbait in my title because this is nominally about GATSBY v2, but it's just about GATSBY in general and why you might want it. And I know not. Okay, just like show of hands, who's like played around with GATSBY? About half the audience. So who doesn't know a thing about GATSBY at all? Has never heard of it. Okay, all right, I have to do a fair amount of introduction then. So yeah, I mean, and this is a sort of spontaneous thing. It's definitely I've spoken here about 6 times, and this is definitely my least prepared, but at the same time, it's my most prepared because I actually worked for GATSBY for a while, and I wrote part of the docs. So I'm just here to talk about what I did, even though I put these slides together like an hour ago. And let's dive into it. My name is Sean. I'm an Infinite Builder, and I'm available on the handle Swix on Twitter. I also work in developer experience at Netlify. It's a static site host. It's really good. It integrates with GitHub. You should try it if you haven't. We're also organizing a Jamstack conference. We're big fans of the Jamstack, which is JavaScript APIs and markup. And it's happening at the end of October. And it's got awesome guests, including Chris Coyer and Wes Boss, and a whole bunch of industry legends, not including myself. If you're interested in making it out to San Francisco, just hit me up. I've got special coupons and stuff. Yeah, it's pretty good. Okay, and I also moderate the React.js subreddit, where there's 71,000 React developers. We help you do everything from getting started in React to getting jobs in React. So if Conductor is hiring, you know where to post your jobs. I also hang out on spectrum.chat, as well as maintain a GitHub repo tracking all the latest stuff with concurrent React, which is now the new name for async React, which will be React 17. So that's all about me, and you don't care about that. You care about GATSBY, and so I'm going to kind of bring you through a theory of static site generators. Like, a lot of people haven't built static site generators, and you've maybe used Jekyll or Hugo, especially if you like posted a blog on GitHub, and so like people kind of know what static site generators are, but have never went through the mental process of making one. And I think that's how you should approach GATSBY, which is like understand what it does for you, and once you know what job you employ it for. You know when to use it and when not to use it, right? So let's make a next generation static site generator. What's the first thing you need? What are if your product manager came to you and said, all right, we want you to make a static site generator. What are the specs? What's top of the list on the specs? And anyone, this is more interactive. Anyone just shout something? What should a static site generator do? Write index.html? Cool. And other HTML files. And that's a typical static site generator. Thank you for that, because this is like meant to be engaging, but it's Wednesday night. So yeah, and let's say we use React. So we have a thing like app.js, and we have all our JSX in there. And then we have different pages like index.js and about.js, and that renders out index.html and then about.html. That is it for static site generation, pretty much, except there's one more thing. What do old traditional static site generators also do? So here I've got a one-to-one correlation with my index. Every single page I define in React generates an HTML file. So what's the next level from there? Anyone?
Also serving a JS file?
You also want to serve a JS file, but that's too advanced for static site generators. We generated a static site. We've made a static site, but we need to generate things. And the word generate comes from using a whole bunch of data that is disconnected to your templates, right? And you can pass your data through your templates and produce a whole bunch of HTML files automatically. And this is really good for blogs, marketing sites, anything where you have a standard template, and then you fill it with data, fill it with images of your products. Let's say you're doing a shopping site, whatever. So here I got a blog, right? So I've got your index.html and about.html, and then I've got content in Markdown, but it could be JSON, it could be in Google Sheets, it could be whatever, like a data source, right? It doesn't matter. And then I pass it through my template, which is a blog, layout template, and then it produces the HTML, right? And so you can stand this alone and say that this is a static site, right? And put it on GitHub pages, and people will be able to navigate it. So this is like this is how the internet was designed to work on HTML. People link to and fro from stuff, and that was it. And then we get to, all right, what else can we do to improve our site? So sorry, I skipped ahead a little bit. Let's talk a little bit about why static site generators are, why do we want this at all, right? We could generate a client-side bundle and just run it like a single-page app, why do static site generation? It's good for hello. Yeah, can you still hear me? Yeah, it's good for rarely updating content. You don't have to run a server, so you don't have like the DigitalOcean Droplet or some other VPS. There's no JavaScript, so it's better for SEO because Google takes a week to crawl JavaScript, and it's more accessible on various devices. It's CDN caching, so you can push your content, all this HTML file, out to the edge, so they can be served from the server, from the CDN caches closest to them. And you're separating content from presentation, which I really like, because I can blog like this, and then I can change around my presentation of the blog independently. And this is really good for keeping your valuable cache of content around. So it's a separation of concerns in terms of data and presentation. So that's a really good. Those are like, that's the case for static site generation. And think about how you would do that with React. Like, do you know everything that you need to do? So these are all the questions I want you to think about in your head. Like, if you were to do this in a weekend, which I did, what would you need to do with the existing React, Webpack, whatever knowledge that you have right now? It's not easy. So then the next requirement is, let's bring in JS. So a single JS bundle approach is what I call this, which is, apart from all the HTML that we already defined, let's have a bundle.js, and let's serve it from each and every single HTML file, the same bundle, right? That's a good first step to making it responsive on the client side. And we use the special word rehydration. And what does that mean? So this is kind of my mental model of rehydration, which is like a freeze-dried thing that you send to space with astronauts, right? So I Googled this. I couldn't find any more modern image, I guess because they're all classified. So this is like declassified image from like the Apollo missions. And so these are dehydrated cereal with milk. And then you rehydrate, you pour water into them. You can imagine your site has been dehydrated into just HTML with no JavaScript. And once they land on your client, they rehydrate it again with JavaScript, and now they're active. They're reactive again, and they're nice, colorful bowls of cereal. So that's the sort of image I want you to have of rehydration. It's literally called that, and this is not a metaphor. So instead of React DOM.render, this is what you'd be used to on your SPA type of situation. So it's React DOM.render, your JSX element, and then your container from the DOM. Instead of that, you do on the server. So this is server-side rendering. React DOM server.render to string. So you render out a string of stuff. You save that into a file somewhere and call it .html. And then in the bundle.js, you do React DOM.hydrate, and you go through all the HTML that was generated and hydrate it out. This is where I would show you a demo that I had running on my laptop, but I'm not running this on my laptop. But I'm gonna actually show you this on the Facebook React fixtures. So a lot of people don't know this, but Facebook has a bunch of tests. But for all the tests that it cannot cover, they have fixtures to do manual testing. So these are basically just demos that are running that show that they let you test various conditions. Unfortunately, I don't have the server running right now, so this is going to be hard to demo. But let me show you the. So this is the source. Is this big enough? Hopefully, this is big enough. Okay. Okay. So this is the SSR fixture. There's a whole bunch of fixtures, by the way. So React Art, React DOM, Expiration. Very interesting, the unstable async feature. If you want to learn about suspense and time slicing, the demos from JSConf Iceland are all here. But here we're going to talk about SSR. So the SSR fixture, here they have a demo app for you. And here they have the importing from the app and the hydrate command that we talked about in my slides. And so where the slides come in is, sorry, where this hydrate comes in is they also have a server side running, and it's an Express app, and it's running, and it's loading a React app, which is here, right? And it's rendering to string that React app. Once it renders to string, it adds a doctype HTML for HTML5, and it renders it out to a HTML file in here. So you can see it exports a render function over here. And when I head over to the index, it imports the render function. It does not import the render function. Yep, it imports the render function here, and then it sends it in response to the slash request, or the GET request for your Express server. So this is a very, very basic server-side rendering implementation with a live running Express server. So this is traditional SSR. What you need to do to make this into a SSG is to just run this once on Node and then just spam it out for every single HTML file that you're supposed to deliver, right? So think about this as like your app is this space of routes, right? You've got React Router, you've got Reach Router in there, and you're flooding out your Node instance to like, hey, let's render like /about, let's render /blog, let's render /products, and then every one of these like generates a whole bunch of HTML. So that's how it theoretically works. Yeah, it's still a lot of work to actually go do it, but that's I just want to establish that theory, because a lot of people when they learn React, they don't necessarily know this because they haven't needed to. So that's what this talk is about. So I want to pause here and actually ask, like, what's the difference between a site and an app when there's hydration? What's the difference? Does anyone have like a difference in the terminology between a site, a website, and a web app?
An app doesn't fully re-render when you change routes?
True, but so this is kind of a trick question. There's no difference, because a static site with React gets hydrated into an app, right? So you're kind of like, the site is your first salvo of, like, you know, if you're fighting a war, you send your troops first, and then you send like the armor division after. So you send your site first, and then you send the rest of the JS, and you hydrate into an app. So a lot of people, I think, from the previous sort of generation of web devs, have a very, very clear distinction between what is a site and what is an app. And they say that static site generators are for generating sites. And that's why there's a bit of a marketing issue going on right now with, like, what are we defining this next generation of static site generators, because they are rehydrating on the front end into an app, and you can do everything you normally would do in an app. So it's more about a delivery mechanism rather than a constraint for your app. So that's something I want to establish. Okay, but let's keep going. So we have established a single bundle. We have a whole bunch of HTML. How can we make this better? This is like audience interaction again. Just shout something. I mean, there's no wrong answers. JavaScript renders HTML page. Is that the answer? Okay, so it does render the HTML already. That's the server process that we run, and that's the static site generation. But it also outputs a fairly large bundle. This bundle contains everything all at once. So when you land on any one of these HTML pages, you load this massive giant bundle. Let's say it's like 3 megabytes, and then and that contains all the data, and it rehydrates that HTML file into your app. So you haven't solved the SPA problem. The SPA problem is where you have a giant bundle. So what can we do to that bundle?
Separate bundles.
Yeah, split it up, right? So how aggressively can we do this? How about let's do it for every single route, right? So this is where you start getting into real insane performance stuff that you would typically do at the end of your process. But how about, like, let's build it into your tool, right? So let's have a smaller bundle, right? And now you see the bundle's gone from red to purple, and we'll talk about why that is. And then we've got a chunk, right? A JavaScript chunk for each and every single HTML. I got index, about, and then blog, and then blog. So every single contains only the JavaScript, the JSX that they need to render, and nothing else. If someone clicks a link to go to the next page, they dynamically import that extra JavaScript that they need to then go render the other stuff. So that's an improvement. What else? This two stuff. So again, we're rendering the same template again and again on the blog post, right? So here I've got blog 1776, July 4th, nothing much happened today. And then 1963, 28th of August, I have a dream. And these are the same, they use the same blog template on both ends, and they're loading the same JavaScript. So chunk 3 and chunk 4 in my sort of theoretical example are kind of duplicate. So how can we make this better? We sort of abstract vendor chunks, which are like the React libraries, which are reusable templates, and we split those out, and we only supply data. So the blog template that we have now in JavaScript has a corresponding chunk, and all the content is just reflected in data. So I've got here data1.json, data2.json. Whatever data format you choose to use, it really doesn't matter. I'm just trying to build out this mental model of what is going on in this new generation of static site generators that we don't see and we kind of take for granted, because all the demos that you see are like, look at how easy this is to set up. But no, I want you to look what this does for you under the hood. How much work would it take for you to do all this in setting up your site? So that's the question I want to sort of kind of ask for you and answer for you. There's more best practices, right? When you know you're making unperformant apps, all of you, like we're all sinners, right? Like, is your Lighthouse score 100? No. And that's why Google does some thought leading around that. Should you inline your CSS to avoid flash of unstyled content? So inlining your CSS meaning you can actually like inline your CSS inside your HTML tag, or you can load it up in your header and make it a blocking thing. So you don't flash your content. Again, I had a demo. It wasn't that good, but it was going to show you something. Actually, I'm going to show you what I did. So anyway, I like went through the process of this, and actually went through the exercise. Can you build this in a weekend? I called it boring SSG because I wanted it to be boring. So this is a demonstration. You can definitely check this out because it's a much smaller code base because it was just done for a job interview basically. But let's look at what it's doing here. Just to show you, because right now I fear that it's very theoretical and you might not be getting what I'm trying to say. Oh, well, the CSS is not that great. So here's a blog, right? It's generating. You can click through different pages. You can generate stuff based on Markdown, right? So this is the kind of blog format that I emphasize. Let's reload and let's try and see. Okay, let's simulate a slow 3G connection, right? And then let's reload this and let's see how it looks. So it's pretty slow. Whoa, I don't know what that is. Oh, okay, and it's while it's loading data, it thinks that there's no sites. So this is the site generator that I built, following that mental thought process that I just walked you through. Like, what would you have to do to make your own? You can see that when I write my own when I write my own HTML and I send it out to you, this is the raw HTML that's being sent. And there's no styling. These are all the default user agent styles, right? But although it does server-side render and this works without JavaScript, it really waits until this CSS comes in for it to be styled, for the whole app to be styled as it looks right now. I don't know how to slow it down actually. But still, I mean, it loads reasonably fast, and if you ran like Lighthouse scores on it, it would do well. But this is a really good demo for how you split up how you sort of server-side statically render your HTML, split up your JavaScript and your JSON into different paths, and all that good stuff. It's a really good exercise to go through. But then I don't take care of all this other stuff, which I'm trying to convince you is valuable, which is you also want hot reloading, right? That's a good developer experience. That's why you use Create React App, and every time you make an edit, you want to see it straight away, so you have a faster feedback loop. Vendor chunks is again another aspect that we want. So like all the React Router, or whatever we use, loading to a big common bundle so we can cache it. Caching validation. This is for builds. So one of the big problems with GATSBY and some of the other static site generators is that a lot of times it takes a while to build, especially if you have 100,000 pages or something. And these are real case studies where, for example, if you're like listing houses, right? Housing apartments and stuff from your data, you're going to have hundreds and hundreds and thousands of listings. So you don't want to build them every single time from scratch. So you want to cache them and you want to invalidate them when stuff outputs. So you want to be smart about how you do that. Data injection, again, like onto your top level site, onto your component level, all this good stuff. Service workers, so it works offline. Data access from multiple sources. Progressive image enhancement is a big one, right? Because a lot of your images, when they first land, you want them to be high quality. Well, you want them to be eventually high quality, but when you first load the page, what about loading a lower resolution version first, or like an SVG drawn like background thing? So wouldn't it be nice to have like a plugin that just did that for you? Because all this in React doesn't care about all this, right? Like React is a low-level rendering library. You need a framework around React to do this for you. Custom fonts for like stripping out like fonts that you don't use, and preloading the next page and this gets into like a little bit of like guessing what your user behavior is. The most recent Chrome Dev Summit showed like how you can use machine learning on your Google Analytics to predict what your user is going to click next when they land on your page. So you preload that page and it will be instant when you click on it. Definitely go check that out by Adi Osmani and the Gatsby team. So on and on and on and on. There's so many best practices. Have you seen the latest front-end developer checklist for 2018? It's like 10 pages. So what about, and there's a general theme for this, and Google calls it the purple pattern, and that's why I'm using the purple color over here, which is very nice, actually. And Gatsby's brand of color is Rebecca Purple, which is an interesting story if you want to go look it up. And it's short for push, render, pre-cache, and lazy load. I don't have space to do that, but we kind of started on that path. There's a whole bunch of best practices to do that. So it's very clear, right, at this point that React just like doesn't do any of this, right? Like we need a framework. So there's too many best practices. We do need frameworks, and there's a whole bunch of them that help us do that. So there's Gatsby, there's React Static, which I just had they're calling for maintainers. So if you want to get involved in open source, especially Hacktoberfest, check out React Static, and then Next.js, which is run by Zeit, and a whole bunch of others, right? But these are the top. And we're here to talk about Gatsby. So that's I just finished. So that was the first part of my talk, and I'm sorry if it was like very theoretical because it was a lot of people haven't been through this exercise of building their own static site generator and thinking about what they want to do. Like a lot of people ask like, why would I need this when I have Create React App? The answer is because Create React App doesn't do any of that for you, right? And these are all best practices for you to build super performant sites out of the box. So Gatsby's mental model is now we're just moving on to Gatsby. And Gatsby's mental model is decoupling CMSs. So their number one public enemy is WordPress, which powers 28% of the internet, which is on the server. They're running, I mean, it's very coupled. And what Gatsby wants to do is be the presentation layer for the web, have a GraphQL layer in the middle, and then have any number of CMSs, 8 headless CMSs. So you can use like Contentful, Netlify CMS, or any other CMS or data source that you choose, including Google Sheets and Dropbox. And I've seen there's like literally hundreds of examples. So you can pull your data from anywhere, right? Run it through GraphQL, and then run it through your Gatsby app. And then it outputs all these static sites that we talked about that do all the good stuff, right? And definitely check out they recently held a webinar where they walk through this introduction for you. So if you're interested in Gatsby, definitely go check that out. But we're here to dive in a little bit. I don't know, I don't know how deep we want to go, but I just want to give you my mental model of Gatsby after having gone through the source code, because it's helpful, especially if you're debugging. Sometimes, Gatsby still has rough edges. It's only about 3 years old. It's helpful to have a good mental model of what Gatsby is doing for you, so you know when to use it or not. So there's really 4 things in the Gatsby sort of ecosystem that lead up to building your site. There's data, right? Every site starts from data. You run it through a plugin because these plugins help you pull in that data for you to use in your app or directly modify your Gatsby instance. And from your app, Gatsby pulls in the plugins and the app to generate your site. So this is the rough idea that I want you to hold in your head. And then we're going to go into a little bit of the docs. I don't think we have time to go into all of it, but I just want to show you where to start. So in a Gatsby project, this is what you get when the first time you launch a Gatsby site. And I just didn't bother making images from this because you're going to look at the docs anyway. So let's talk about the docs. When you bootstrap a Gatsby site, you're going to get all this, right? So this is source. Can you see this? Hopefully it's big enough. So inside the source is your Magic Pages folder where you hold where every single component in your pages is dynamically generated, and your templates which are generated based on your data. So it's similar to how we generated our blog earlier. And then they implement all these hooks, lifecycle hooks inside Gatsby config, Gatsby node, Gatsby SSR, and Gatsby browser. So these are all the stages of life in Gatsby. So first they run through node and SSR, and then once they land on the client, then they run through Gatsby browser. The interesting thing that you have to know about how Gatsby works under the hood is that so that was the Gatsby app, right? And how you write Gatsby, that's the source file over here. The interesting thing is that the plugins also implement Gatsby config, Gatsby node, Gatsby SSR, and Gatsby browser. So this is what I want to draw your attention to under the hood. These are the docs that I wrote, which sort of guide you through how the bootstrap sequence happens in Gatsby. So first of all, you load in all your plugins in your Gatsby config. So these plugins can include adding a service worker, adding Google Analytics. Like it's just like a one-liner. It's insanely easy, right? And then it initializes the cache, pulls in all that data, right? And it calls those data points nodes. From each node, it generates a page, like an HTML page, right? And then and every plugin also can implement all these lifecycle hooks from that list of plugins that you initialized earlier. Once you initialize those plugins, it runs the GraphQL query by standing up a GraphQL server. So you have a GraphQL interface to pull in all that data. And it's really nice developer experience by doing that. Once it does that, it writes out the pages, which is all the .html, the JavaScript, the CSS, all that good stuff, into the cache, which as we saw earlier, is part of that file. So this is the smart cache where like you want to definitely keep files around if you're not changing them at all. So that's approximately how Gatsby works. I did get the 5-minute mark, so we don't have time to go further. But it's really well documented, and it really is insightful as to how Gatsby is implemented. And you can definitely hit me up for a detailed walkthrough because this thing took years to write. And I think it's one of the most interesting feats of React engineering there is out there. So if you're interested in like really solid React apps, check the code base out. Gatsby v2. So that was the second part of my talk, which is all about Gatsby. Just a little bit more about Gatsby v2, and then I'm done. So Gatsby v2 was launched about a month ago, and really it's more of an incremental upgrade, but it's incrementally good, very good. So they updated a lot of their downstream dependencies, like React 16. So React 16, because of React Fiber rewrite, went down by 30% in size and obviously increased in speed. Upgraded Webpack and Babel, and then moved from React Router to Reach Router, which is also smaller and more accessible. Definitely read up on all those if you're not familiar, because these are very, very clearly very important things in the React ecosystem. They also implemented a new API called Static Query, so you can co-locate. So this is a component, and inside the component it defines its own data requirements with GraphQL alongside its own view layer, which is how it's going to render. And so that's an incremental improvement from previously, where Gatsby you defined on a page level what your data requirements are, and you passed it in through props all the way to your components as you needed them. So if components knew their own data requirements, you can definitely disconnect them from their parents, and you can reuse them a lot better. So Static Query is really awesome. They also implemented tracing, so you can see when you see all those like life cycles, like how long each of them are taking, and whether any of them are roadblocks. So this is really good. It uses Redux under the hood, and you can see all the Redux events going on in here. This is probably one of the biggest Redux implementations out there in open source. And my final point, right, is I want to bring you back, all the way back, all right, come back to your mental model of how React apps are made. So first of all, this is how create React app, and most people learn React, which is client-side SPA, right? The server does minimal stuff, sends a big bundle of JS over to client. Client does all the work. It's big, it's slow. Server-side rendering, incremental improvement. Server does all the work and then sends the client stuff. So and it's smaller, it's happier, and that's why I have a little smiley face there. The Jamstack is where everything is moving these days, which is static site with like this next generation static site generators. You push stuff through GitHub. It does the CDN does the work. For example, like Netlify, which was where I happen to work, and it does that minimal amount of work, and then it pushes stuff to the client. So that's ahead of time rendering. That's the Jamstack, and this is part of the whole a broader trend of the age of ahead of time, which a lot of people in other frameworks are also investigating, like with Angular Ivy, Vue, VuePress, Svelte, and Sapper, and React Fusion was just announced yesterday at Framework Summit. So definitely check that out as well on the subreddit. And you're welcome to join there, as well as Gatsby. So this is pushing all that rendering stuff ahead of time so that your client doesn't have to do it, and it renders performant apps much faster. So that's my Gatsby talk. It's a lot of content, I know, but I hope I piqued your interest in like diving under the hood, because it does so much for you. And definitely check it out. Talk to me about it. Thank you. Oh, do I take questions?
Yeah.
I take questions?
Questions? I don't think, maybe one question.
All right.
Anyone? Asking one question. Anything? Yeah.
Where did the Gatsby come from?
Just repeat the question for the...
Question was where the name Gatsby come from? I don't know. Ask Carl Matthews. I don't know.
Thank you. Thank you, Sean.
On this mic? Should I move it higher?
Just
Oh, we're good? Okay.
We did.
Awesome.
All right, go for it. Give him a round of applause. Come on.
All right.
All good?
Yes, I just need to restart things that...
There is enough vegan pizza for everyone. So...
Okay. Yeah, of course.
The vegan pizza looks like the carton of the real pizza.
All right. You guys hear me well back there? All right. So my name is Robert Beliki. I'm an engineer at Jetty. We are bringing renter's insurance into the 21st century. It's an absolutely great place to work. We're hiring front end, back end. That's all you're going to hear about Jetty for now. I would absolutely recommend, if you're looking for a place or know somebody good, to pass them on to me. So today I'm going to be talking about writing React without race conditions. React gives us this great promise. Like, it's simple. You have this declarative render method, which takes some state, goes through a pure function, and returns some DOM. And everything is so pure and it's so beautiful. And yet every single time we go into a larger React app, there's unnecessary complexity. We have to rely on other frameworks to manage things. And inevitably, in some edge cases, it's broken. You might go to a user profile and twiddle with the user ID in the URL, and something will slightly be off. If your internet is slow, something will slightly be off. Any non-trivial React app, like if you mess with it enough, or if you have enough users, somebody's going to find an edge case where something doesn't work properly. So I'm going to talk about, in this talk, how we at Jetty go about building React in such a way that it doesn't have race conditions. The motivating example that I'm going to show you is this little autocomplete here. I don't know how well this is going to come through on this, this video, but basically what I'm going to do is bash this autocomplete, and it's going to send out a request, a fake request in this case, every single time I type something. And every single time a request comes back, it's going to show you what the autocomplete results would be for that. So if I type hello world, what you see is all these requests are coming back. And in the end, it settles on hello world without a D. So you're thinking in your head right now, come on, Robert, we're better than this. I wouldn't make that silly mistake. It's obvious that you need to write your React components better. And instead of trying to reach for some way to avoid race conditions, you should go back to school. And the answer is you're right. In this specific case, it's easy to fix this autocomplete. But once you start worrying about other people's code, once you start having an app with multiple parts that are interacting, once you have to start reviewing and thinking about all these things, you can't be sure that everything is correct. And then when you go to a non-trivial large React app, you're going to have race conditions, and something's going to be broken. So with that motivating example, let's get started on this. So to take a step back, the simplest model of React is as follows. You take something which has some state and has some props, pass it through a render function, and that spits out some DOM. This DOM has event callbacks attached to it, which updates some state, and then the circle of life repeats. For our presentation, we don't really worry about these props. They don't add anything to our case. So just think of it as some state goes through a pure render function, the render function, spits out some DOM. It can be updated, and we get new DOM. This is simple. And what's nice about this model is it actually encompasses a lot of things. You can build a text input. You can build a toggle switch. You can build a drop-down. And the nice part about that is it's really hard to mess up. If you're building an app where there's a toggle switch, and when you click that toggle switch, a light bulb on the other side goes from lit to not lit. You click it, it flips. Really hard to mess up. You could click that toggle switch a million times as fast as possible, and you're guaranteed to not mess that up, unless you're going out of your way to do this. Of course, you can't do things like make API calls, use set timeouts, stuff like that. Other things that are kind of useful when you're actually doing real-world things. So let's complicate this example of React slightly. So first, we have some state. It goes through a pure function called render, spits out some DOM. This DOM has event callbacks, which trigger asynchronous requests. And once those requests come back, we get some sort of payload. This payload gets passed to a function, usually what's in your then block. This function knows how to take the current state and the event payload and update the state. Awesome. This can handle a lot more. It can handle an autocomplete, which makes API calls. It can handle loading a user profile. It can handle a data table with a bunch of filters. It can handle pagination, all that stuff. So what's wrong with this situation? Everything sounds fine so far. React is still perfect. There's no real complications. If you have one API call that's guaranteed to succeed, then you have one path through 3 distinct states. No request, request loading, request finished. If you have 2 API calls, you have 3 paths through 10 distinct states. If you have 3 API calls, keep in mind that these are all API calls that are guaranteed to succeed. We're not even dealing with API calls that might fail. You have 15 paths, 4 API calls, 105 paths, 5 API calls, 945 paths, 6 API calls, over 10,000 paths. So basically, the number of paths increases with n factorial. So clearly, we're going to be making some simplifying assumptions. You're not going to have separate code handling every single one of those cases, nor do you want that. So to begin with, you could make a simplifying assumption that there's only one request at a time, or a total of one request. Loading a user profile is like this. You can make a simplifying assumption that all your requests are going to be debounced. So essentially, there's only one request at a time. You can make the assumption that all the assumptions will come back in the order that they were made. Probably not a great assumption to make, but certainly a lot of apps do this. You can make an assumption that many of these intermediate states are equivalent to each other, and the meaning of that maybe depends on your actual app. You can cancel previous promises, which is essentially a way of saying that there's only one request going on at once. And what I'm going to be arguing that you actually want to do is to only render the results of the most recent request. So let's think about that last bit. Does that even make sense? If we have an autocomplete, this Google, you type hello world into Google. What are the results that you want to see down here? you want to see the ones that have to do with hello world. Even if Google had made a request for hello, hello W, hello WO, all that stuff, all of those you're going to ignore. You want to ignore. The proper behavior is to only render the results that came back from the API call that was associated with hello world. If you have some sort of data table with some filters, which was created in the year 1995 and still available on Google Images, you want to show the results in the data table that correspond to the current state of the filter. If you have some sort of pagination and you click around on page 1, page 4, page 5, page 4, end up on page 4, if you're showing anything besides page 4, once everything's finished loading, you're doing it wrong. So what do these all have in common? The API results that we want to render on the page correspond to the current state of the UI. So the thing about that is it sounds kind of simple, but there's actually a lot going on here. Basically, it means that fundamentally, we can throw away everything that happened beforehand. And what's difficult about throwing away all the API requests that happened beforehand is that they're already out there. They're being executed. The then block will be called. So you need to worry when the API calls come back, do I execute this then block or do I not? So you need to sort of keep track, like whether it's by counting requests or whether it's by having some sort of unique ID. You need to do something so that when API calls come back, you only update the state if this is the API call that you're still worried about. So right now I'm going to start showing you some code. So as in any presentation, when I show some code, your eyes will glaze over. So just remember the motivating example is the autocomplete that I showed you early on. Basically, I want you to think about bashing the keyboard. Every single time you type a character, a new API call is made, and we only want to render the results of the last one. So what I'm about to show you is a perfectly valid basic implementation of this. We're going to start with an autocomplete. Is this a little too small? Okay. I'm not going to do anything about that now. So we have an autocomplete. The important thing is that we keep track of the request ID. And in this onChange method, every single time we make an API call, or we type something, we increment that request ID, we store it on the state, and then inside this then block, we check whether the request ID that's on the state corresponds to the request ID that we had just set. So this means that if I type A, I set request ID to 1. When that promise comes back, if it's still 1, we know, good, you haven't typed anything else. But if you type ABC, this.state.last request ID is 3, so the then callback for A and AB are ignored. They fail this if test. So that's nice. But it's not that good. First off, there's lots of boilerplate in this case. It's imperative. It's really easy to screw up imperative code, to try to take some shortcuts here, and it's sort of, there's more ways to screw up imperative code than there is declarative code. So we can do better. So let's come up with a declarative version of what I just mentioned. And here we're getting very close to what we do at Jetty. So now we have a declarative autocomplete component. So this guy keeps track of the state, the text on the state, and it keeps track of the autocomplete request. In our onChange method, we update the text on the state, and we also set the promise, the call to fetch autocomplete, on the state. Now, the astute among you might look at that and think, can we store a promise on the state? And the answer is yes. You can store whatever you want. There's absolutely nothing preventing you from doing this. Now, in our render method, we actually can't access the results of that autocomplete request in the render method. Why is this? Autocomplete request is a promise. You can't access the value synchronously, so you need to have a call to set state at some point in time for this to work, right? Wrong. What we're actually doing here is passing that autocomplete request to a resolve component, which we're going to get into later in this presentation. And that component does the work of unwrapping the promise and rendering and calling this then render prop if and only if this promise has resolved. So what we're doing here is much more declarative, and it's a lot easier to reason about. And it's a lot easier to look at somebody else's code and say, OK, you use this resolve component correctly. There's only a few ways to use it. I can reason about it. So what's nice about this resolve component is that all the functionality is in there. We take it out of 20 different places, put it into one. It's a lot more dry. It's generic and easy to reason about. One of the principles of computer science is that if you don't know anything about your parameters, you can do very little with them. So the only thing we know about what we're passing to the resolve component is that it's a promise. We don't know what type of promise it is or anything like that. So it's a lot easier to look at the resolve code and say, it works for any sort of promise, therefore it works for all promises. It's small and easily testable, it's easily reusable, it's declarative, and later on we're going to add more functionality to it and we're going to get it everywhere. At Jetty, we use this library React Promise. We use a version of it, a fork of it. I would highly recommend looking at React Promise. It is a mind-bendingly good implementation of what I'm talking about. You should absolutely use it in your apps. So let's think about what we actually want out of resolve. So this is the API that I want from a resolve component. It takes a promise, and it renders one of 4 render props. Before, if there's no promise, then if the promise is resolved, catch if the promise failed, and pending if the promise is loading. Sorry. Pay for your software, people. Just kidding, I just haven't updated it yet, but I paid for it in the past. So what do we want out of this? We want 2 things. One, that it will render exactly one of these 4 things. So basically, it's a 4-way if-else statement that's in JSX. And that it will only ever pass data corresponding to the current promise that's being passed to it. And it will always be in sync with the current promise. So let's think about how we would do this. And I want you to think about the parallels between what I'm about to show you now and what we did with last request ID in the autocomplete, in the initial autocomplete implementation. So if you want to follow along, you can take a look at this link here. The link to my presentation is available on the Meetup site also. But if you go follow this link, you'll see the internal implementation of our resolve component. So the resolve component has a component will receive props lifetime hook, lifecycle hook. And if the promise has been updated, if it's a new promise, it's going to call this.handle promise. Inside of this.handle promise, we set the state, we set the promise on the state, and then just like last time, we check in the then callback whether this.state.promise is still equal to that promise. So that's nice because this means that if I have an autocomplete, I type A, I call fetch autocomplete, I set a promise on the state. I type AB, I clobber that previous promise, and the first promise is no longer ever accessible, and we have no way to accidentally render it, no way to have any race conditions that will show it somewhere in some weird edge case. We're getting rid of the initial promise, we're clobbering it with the next one. And that means that as I type A, B, C, D, E, F, G, every single time I'm clobbering the last promise, and at the very end of it, the promise that's available on the state is only the one that I actually care about. So what have we accomplished? What's nice about this is that it's really easy to write an autocomplete that doesn't actually do the autocomplete. If you're just accepting text input and updating your state, you're never going to screw that up. And the reason for that is that the updates to state happen inside of event callbacks. But the moment you start updating your state outside of event callbacks, it starts getting complicated and you start having to reason about this. what you'll notice in this previous example here is that the only time we updated state was in an event callback, when we updated autocomplete text, which, as we just reasoned, is pretty hard to screw up. And we also set the request at the exact same time. So what we get for free by using a resolve component like this is that all of our async, all of the reasoning about async code is just as easy as reasoning about synchronous code. And if you've used React for more than a week, the synchronous part is fine, is easy to do. Next, all of this is in a single, isolated, testable components. Also, we're not debouncing requests. We're not blocking the UI. This is 2018. If you have to wait 300 milliseconds because your company doesn't know how to handle asynchronous requests without sending your app into an inconsistent state, I mean, we can do better. Blocking the UI every time you toggle some sort of UI, also user hostile, and we can do better. And of course, no more race conditions in this case. So that's it. Just kidding. We can do better. All right, so one of the things that's nice about Resolve is that it's a centralized component. That means that you have it in like 20 different places. We can add more logic. So one of the things that we added at Jetty is that we keep track of the last successful value and the last error and the last promised state. So this means that normally if you'd have a request, like let's say you have a user, you're trying to fetch a user, you would normally have a spinner, and then it would either show the user afterward or show an error. Now, let's say you update the user. You would go back to having a spinner, and then it would go back to showing the user. What we're trying to accomplish with this is if you have a user already and you update him, you can continue to render the user, and then once the new data comes back, show that user, also without race conditions. So let's take a look at this in practice. So this is Jetty's website. Let's see if I can zoom this out a little. OK. What you'll notice right now as I type these things is that this goes spinning. Nothing here, if I'm fast enough, nothing gets blocked from the UI. And at every point in time, we can still interact with the UI. Now, let's say you're on a train, you're picking out your renter's insurance policy, and you just really can't stop doing it, but the train is going underground. So you're in a tunnel, and you try to update something. Oops, seems like our site is having some issues. We don't know if the back end is down or if you're disconnected. So you can do things like click try again. You can continue to interact with the UI, and it continues to show the old price, but you can't really do anything about it. You come out the other side of the tunnel, and you click try again, and it's loading, and that error overlay was still showing, and then once it finished, it went back to this situation. Now you're going to have to take my word for it that the price that I'm showing you right now is the correct price. And if we had modified something else, went into another state, you would still be shown the correct price. But what's nice about this is that right here in this little card view, there was a non-trivial amount of functionality. If the last promise that finished errored out, we need to show an error while it's pending. Otherwise, we don't show any overlay on top of this card while it's pending. That's something that we basically get out of the box with this. And what's also really nice about this is that the previous implementation of this, the amount of permutations that you had to test, the amount of edge cases, it was mind-boggling. And the answer was that we didn't do it. And so it was broken in all sorts of weird ways. If some errors broke, if some errors failed, some requests failed, we might not handle that exactly correctly. And we lied to the user by telling them that we would offer them a quote at a particular price when in fact we wouldn't do that when you actually clicked purchase. Yeah. So let's discuss what we did, what we can learn from this. Set promises on state. Don't be afraid of that. Be declarative, always. Use a resolve component as a four-way if-else statement. And never, ever call setState in an asynchronous callback outside of one part of your app, which is inside the resolve component. That's my presentation. I'm happy to take questions. Yeah.
So one of the things we deal with, like at my company, is having multiple API requests that will ultimately affect the same like rendering block. So like different API requests are updating like the same state, right? So like I see this working super well when the same endpoint is being hit, and then like the previous requests to that endpoint are clobbered, and then like the stuff works pretty well. So how do you approach that kind of scenario, or is that just bad design?
Okay, so the question was, what if you have multiple API calls that are required to render a single user profile? Is that right? So you have to fetch the user and you have to fetch like the user's interests or something like that. So what you'll notice is that what you pass to the resolve component is just a promise. So in that kind of a situation, I would pass promise.all and then give it an array of the two things that it needs. Like promise.all this.state.user_promise and this.state.what the user likes promise, right? And then every time you needed to update one of those, you would just set that promise on state. So I would just combine those into a single promise. There's the other possibility that you have sort of like nested promises. You have a user profile on the outside, and inside you have some other stuff, and they all combine in some way. That's actually what we did here. Let me see if I can still press back. Okay. So all of these guys are setting different promises. And then when we set here, they all end up rolling up into this thing. So we're basically passing down this promise down the chain, and this whole thing is rendered. This whole thing is within a resolve component. And then there's another resolve component here that shows us this button. So you can nest them and have this guy spin only when necessary, and have the whole thing be inaccessible when the initial promise, like fetching the initial data, hasn't finished.
Any other quick question?
Yeah.
One of you. Let's fight for it.
Have you experimented or considered generalizing this to reactive streams instead of just processes?
I haven't thought about that, honestly. I think it would absolutely work with it. Basically, setting the promise on the state seems equivalent to just having a stream where the next value is the value that the stream, when you call set state, that's the value that the stream emits. So I think it would generalize pretty well to that. Sorry, the question was whether I've thought about using reactive streams with this.
Thank you. Thank you very much.
Thank you.
I'll take
No,
it.
no,
Okay.
sorry.
Yeah,
Oh, yeah.
okay,
There we go.
And raise your hand. All right. Not too much. So the rest of you, are you ready for our traditional ReactNYC quiz? Are you ready? Yeah. Woo! The only quiz in town that has no prizes at all. So you basically have absolutely no reason to participate. Let me just fix my resolution. Shouldn't be. All right. Take your phones out, please. Just before we begin, take a moment to read our privacy policy. All right? Agree? All right. So, go ahead to kahoot.it, enter this code. Let's see if we can get some ridiculous music. Yeah. Come on. Help us, the organizers, to know you better. You can use your real name, you can use a fake name. We don't care. Is there anyone trying to connect? Still trying to connect? Someone? Just you? 40 people? 42? First call? Can we get 43? No? Yeah? 43? Let's try to hit 50. 50? Can I hear 50? Yeah? 45? First call? Yeah, it's gonna end up for 35. Is there anyone else trying to connect without any success? Please let us know, because there's absolutely nothing we can do about it. Alright? When we get to 52, we're gonna start. We're gonna start anyway. I lied. So, for the few of you that are like doing this for the first time, you'll get 20 seconds. You'll get a question. Please be honest, because we save this information and then we just delete it from the trash. Ready? Ready? Well, we need to get some prizes. They're not like... Alright. Yep, Halloween on the way. How well do you know React? Not at all. Please teach me. That's the reason I'm here. I read the docs. That's most of it. I'm fine. Or I'm a ninja rockstar React development machine. Yeah, maybe you are. But be careful with your answers. Yeah, alright, I'm fine. Where are the React development machines? Please raise your hand. Raise your hand, don't be shy. Yeah. Alright, cool. Are you looking for a job? Be honest, it might help you. If you're married to an old rich husband and wife, or wife, you don't need to worry about the job, yeah? Just be patient. How can you look for a job passively? Who's hiring? Raise your hand. All the job seekers, all right? Locate those people and attack them when we go to our break. I'm a front-end developer because, yeah, I want to change the world. Or my last music album was a total failure. Or I failed a job interview at McDonald's. Makes sense? Alright? Sometimes happen, or just for the money. Let's see how honest you are. Who fails a job interview at McDonald's? That's what I care about. 12 people. Raise your hand. Yeah. Yeah, those job interviews. Come on. How old are you? Don't worry, this is completely private data. Yeah. Yeah. Let's see, how old are you? Do we've got beer here? Yeah. How many ICQ? How many MIRC? Who used Qtext? Raise your hand. Just you? The rest of you never heard of Qtext? Oh, come on. How many meetups a month do you attend? Are you a meetup animal? Yeah. If you ask yourself, what is a meetup? Please be honest. We're gonna share this information with everyone on Twitter. How many hopeless developers? All right, raise your hand. 31 meetups a month. Yeah. What would you do for the ReactNYC community? It's time to give back. All right. It can be easy, like spread the word at ReactNYC through Twitter if you want to give a talk. Would you catch a grenade for us? Would you shave your body hair while we live streaming? Now, I want 10 people to raise their hand. Just you? Look at him and come visit us at ReactNYC anniversary. It's going to happen on February, I think. It's going to be a body hair party. Yeah. What else should we do at ReactNYC to make you feel more happy, comfortable? Would you like some social mixers? Would you like to do something radical, unrelated to tech? A special event about Angular, Vue, the other frameworks out there? Yeah, actually that's a very serious question. 25 hackathon, let's build something together. Alright, those 25 people, are you ready for a hackathon through the weekend? Is that fine with you? Like, get together for the whole weekend and, I don't know, build something useful. What do you do on your free time? Let's get to know you better. How many Celine Dion fans are out there? Not too much. Most of them at VHoT4N43jK8. How many of you coding on your free time? 90 people. That's impressive. All right, Celine Dion fans, raise your hand. We can help you. Contact the organizers after. Right. How big is your front-end team? You see what a wonderful quiz. It's like a great balance between like very good questions and informative stuff and bullshit. The horse got nothing to do with mothers. All right. Just me and my mother. Please, 21 people contacts the organizer after the meetup. As well, almost the last question. Why do you come to ReactNYC? Yeah, we are a very inclusive community. If this is your only social life, that's perfectly fine. We'll be your family. All right, who's here to find his future husband or wife? Raise your hand. Oh, good. Sean. Sean. Really? Did you know that Sean is an instructor at Egghead.io? That's cool. Yeah. Impressive. No, I'm serious. And he's looking for his future whatever. All right. Last question. Where did you came from? Where do you live? All right? Yeah. I live in New Jersey. I live in the forest, yeah. I'm always telling the truth. I can show you pictures. I'm surrounded with ducks. Yeah, 12 people from New Jersey. Woo! Ah, yeah, actually I've got nothing to say about this question. Thank you very much for taking a part of our traditional quiz. We're gonna get a short break, something like, I don't know, 12 minutes. Yeah? So you can grab a pizza or whatever. And after the break, we've got Sergeant JSX. Who's familiar with Sergeant JSX? You've seen it before? All right. Special guest. So stay tuned. I'm gonna put a timer now. Countdown. What's happened to the screen?
Am I still alive? Ah, you have this. Yes.
No one saw this, so it never happened.
Am I still alive?
Give it. Stupid thing. I think you lost 3 fingers. I can hear the other one. Oh, we try not to move it. Can you put this thing inside a hand grenade? Please? Thank you. Alright, but seriously, people asking why I'm so like into WebStorm, so I want to show you just, we can spare like a minute or two to show you some things that I think that are very powerful. So for example, one of my favorite features would be, oh, you did so much damage. Come on. Like if you've got, I don't know, some kind of component. So very easily with great refactoring features, you can refactor it out to a React component. Wait a second. This is too much zoom. All right. So you can extract component. You can just choose the text, choose whatever you need a class functional component, and let's call it title. And let's say it's going to be a functional component or class component. Start with this. So it's going to extract a component out to a class, and then it can easily you can easily change it to a functional component if you like. But actually, what I want to do, I want to take this and I want to move it to a new file. So we can just take it out and move it to another file. And what else is fine about React support in WebStorm? Actually, I don't remember what I want to show, but you're gonna see it in my live coding. But this is one of my the most favorite features, for sure. Let's try to do another one. Let's try to do a P with a H3, and let's render here something like this props title. And let's see what's gonna happen if I'm gonna try to extract this one, but to a functional component. Yep. So it's refactor everything. It's adding prop types for free. So those kind of things may looks like like a toy, but when you're creating a bunch of components and you're building large components that start to break them down into little pieces, it can save you tons of time, and this is my favorite feature. But you've got other benefits. I've got here free licenses for any ID, not just WebStorm. So if you cooperate, you will get one of those. And this is a lifetime license. We're not playing games here. But it's not for you, Sean. Where are you? All right. Yeah, we're done with the fingers. We're done with this. All right. So, let's get to business. I'm going to teach you today one technique to improve performance with React. It's going to be simple but powerful. I'm going to introduce you probably the right tools that I think you should use. One of them is choose a good IDE, whatever you with VS Code for some reason, or WebStorm or whatever. Make sure that your tool that you're working with is helping you to achieve the target. You need practical knowledge. You're welcome to join one of the community workshops that I'm conducting, where we build React from scratch with just vanilla JavaScript, because React might seem small and easy to use, but you'll be surprised how much sophisticated but easy it looks like under the hood. And like I said, I'm going to teach you just one technique to achieve this. All right, let's get down to business. Where is my WebStorm? All right. So what we're going to do is this. Let's change this to app. Let's make sure we're up and running. Sean, what have you done? Just broke everything. So I'm just gonna, I think I'm gonna, where are you, on the index file? Yeah. Let's import this. Let's go to app. All right. Cool. Now, because it's going to be live coding, can you see the code clear? You want it to make it a little bit larger? All right. We're going to do real live coding, so if you see some problem, please code with me. Please interfere me if you see that I'm doing something stupid, so we won't waste our time because I missed, because I had a typo or something. All right? So we're going to start our journey by creating a React class. So we can get rid of this. And inside of our React class, we're gonna introduce some state. Let's do this. Let's create the state objects. Let's create an array of man, an array of tanks. Inside the render function, we're gonna log app render. And right here inside the render method, let's do something. Let's start by, I don't want a div. Let's create a title, Warzone. We can use fragment here. And let's do this. Let's create this state map. Let's take the man. And return what we want to return. Let's create a UL here and return an li with image tag. All right, pretty basic. Get rid of this. Let's import some pictures. So we've got a tank JPEG, we've got a man JPEG, and just get rid of those. What? Where? Yep, that makes sense. So, thank you. Here we're gonna just, this is a man, so let's use this. And actually we can copy the entire UL and create another for tanks. So this one gonna be, we don't really care about the content, so I'm just gonna call it T, and here we're gonna render a tank and add two buttons. This will be add man, this will be add tank, and actually both of them need the on click. This is gonna be this add man, we're gonna implement it in a second, and the other gonna be add tank. Up until now, very basic, but it was very important for me to write it down from scratch, even though I could create a template for this and just, you know, copy paste stuff. But I don't believe in copy paste, because when you copy paste, you don't have, when you do like live coding with copy paste, you don't get any errors, and this is not real life. All right, add man, we're gonna do a this set state. I'm gonna use a function. So I'm gonna take the current state, that's the way I like to call it, and return a new object. We're gonna override the array of man with, actually, we can take from here, we can destructure this, we can take the man, spread it here, and add another one. Same thing for the tanks. Any questions about this code? If you've got one, that's perfectly okay. If you find it very straightforward, that's fine. If you've got something to ask about syntax, about conventions, feel free to do it. All right, cool. Happy to hear it. I'm using Create React App, and I just generated a project before I got started. So this is Create React App 2. That's the reason I can use this, because they've got the Bubble plugin that supports this, so it's not just optional. If you're not familiar with this is Fragment without the need to import Fragment. All right, I'll share the code with you after it. So if you want to play with it, that's nice. So now I can add soldiers, and I can add, almost can add tanks. Oh, it's right here. You know what? Let's fix it. Where's my index.html? John, have you done something with my CSS? All right. First questions. Let's start to talk about performance. I'm going back to app. How many times app got rendered? What's going to trigger app render? You have to cooperate. It won't move forward. Trust me. I know basics. Answer. Setting the state. So when I add a man, app renders? Cool. When I add a tank, app renders? Make sense? Another questions. You see this tree of elements right here? The DOM that was created for me. Now I'm going to add man and add tank and call the render method of this one component that I've got. What's going to be rewritten to the DOM? How many elements? Your best guess. Just one? If I'm going to hit add man, how many elements going to be rendered to the DOM? The render is going to be invoked. You've seen it. The render method is going to be called. But how many physical elements the browser going to render? Who think one? All right. For all the others, the first thing that you need to know that calling render doesn't mean DOM manipulation. And if you're not familiar with this tool, that is built in your browser, rendering paint flashing, if you check this on, you can actually see, let's try to refresh it, all right, how much work the browser does. But right now I see something interesting. What's happening? They're all being rendered. The whole list being rendered, although I'm just adding one item. And the reason for this, I've only got one component. So if you ever reason about, is this breaking into components mean something? Not just code organization, not just splitting the large components to be able to maintain code? Yes, it does. So even if you've got a simple app like this, don't be tempted to keep this UL here inside because you're going to hurt performance. I'm going to try and do something like this. I'm going to take this JSX and just create another class. Let's call this man. render, return. Let's return all of this. Instead of this state, man, let's say props. We're gonna pass it as props, and here we're gonna log man render. Make sense? Another class component. All right. So now right here, I'm gonna use it, man, and I'm gonna pass it this state man. Make sense? Still got an issue. I'm gonna fix it. All right. Now question. Back to the console. You can already see the answer. When I press add man, the man component is going to render? Yes. When I press add tank, the man render going to happen? It is. And why React is not able to just render the item that I added? I'll give you a hint. You've got a very bold red warning right here because we didn't provide a key. So if you ever wondered, is this warning is for real? Is like passing a key when I iterate over element is that important? Yes. This is how Reacts know to render just the element that you added. To be able to compare the virtual DOM and the real DOM. So what I'm going to do, I'm just going to do this. I'm going to take the index and let's try to pass a key and pass the index. And let's see if things got better. All right? So I'm going to add man. Doesn't seem to have any effect. Why? Who knows? I just added a key right here, so I expect React to know what it's doing. But this, what? I can't hear it. No, that's not a problem. The index wasn't unique enough. I'll let you think about it. I'm gonna give you an answer. Don't worry, all right? I'll let you think about it. But now I've got another question. Men render, even if I just click on add tank, I'm not passing new props to man, but man gets render anyway, because it's part of the app render structure. Make sense? I want to prevent it. I don't want, when I press tank, I don't want man to be rendered. What can I do? Which lifecycle should I use? Should component render. So I can come right here and start typing should component render blah blah blah. And if you're not, if there's anyone here who's not familiar with should component render, raise your hand, don't be shy. All right, should component render. Yeah, I can see it. It's right here. Should component render, you can see what's the next props and the next state is going to be, and you can compare. If it returns true, the component will call render. If it returns false, it won't render. So I can say, look, from those next props, this is the man, yeah? I'm going to take this prop, and if this prop is not equals, the next prop not equals to this props.man, don't render. Make sense? I think I've got a typo. Should component, update, yeah. Too late for me. All right? So this is an optimization that we can do, and now when I add a tank, the man doesn't render. Let's get rid of this error. I'm gonna come here to, let's do the same trick. Let's pass an index and li key equals to index, just to get rid of this annoying message. So now I fixed the problem. I'm adding a tank, just the app render makes sense. The man doesn't need to be rendered unless I'm passing different props, and then the man gets rendered. Cool? Nice. Who's seeing this for the first time? Not too much of you. All right, cool. But I don't want to do it each and every time. So I don't want to re-implement this. It should be obvious. If the props are different, render. If are the same props, don't render. So the best practice would be don't extend component. Extend pure component. Extend pure component by default. If you need to create a class component, what's the reason for creating a class component? If you need to manage some inner state, if you need to make use of lifecycle methods, make sense? There's a lot of reasons. But I don't want to repeat this should component update again and again and again. So I'm saying take it as a best practice. In most cases, instead of just extending component, I'll take 10. Extend pure component. Who's seeing pure component for the first time? A little bit more. All right. That's cool. We've got optimization. But I want to show you another tool. Console logging is like, come on. You want to know how much components getting rendered, so you console log. I like console logging. Yeah, I believe that the best debugging is console logging. But there must be a better way, and there is a better way. So, if you're not familiar with the next feature on the React Dev tool, you can go to Profiler, hit Record, and start interacting with your app. And then press Stop, and you know exactly how many times each component has been rendered. For example, I can see that the man component, how much time it took. You see it's getting better, the timing from time to time, and it was rendered 5 times, which kind of makes sense because I added 5 men. And I can go back and look at the app and how much time he got rendered. All right? Who's seeing this tool for the first time? Nice, it's getting better. All right, don't worry, I'll be on time, hopefully. So, what we learn? Don't worry, there's more, all right? What we learned up until now? Maybe we learned some new syntax. We learned about that calling render doesn't mean necessarily rendering the DOM, but we've got some kind of a bug because it doesn't look like I'm rendering just what I want. We learned that there is this thing, pure component. It's documented, it's part of React, and it's just a class component that implements should component update for you and doing a shallow comparing. So in most cases, that's exactly what you want. When you're getting props, render. Same props, don't render. You don't need to do it by yourself. All right? Now that's cool, but I'm feeling a little bit bad about this because I just created a class component, and on this use case, I don't really need a class component. I can use functional presentational component. That's the beauty of Redux. Let's do the same thing for the tanks. So I'm gonna take this code, but instead of creating class for no reason, I'm gonna do this. Tanks equals, let's just, let's stay pure all the way. Let's extract tanks from props. Oh, yeah, sorry. Let's extract tanks from props. Beautiful, pure, functional, presentational, a lot of buzzwords components. All right. Let's see how much time it's getting rendered. So I'm going to take all of this and just add a return. Just so I can do this, like tanks render log, and right here tanks, and let's add tanks this state thanks. Cool. I think I'm on the right way. Console. Add man thanks got render. Same issue as before. But don't worry, we can extend pure component. We can implement should component update. Yeah? Can we? Can we? No. Why not? Because it's, say it loud. Who said this? Who just answered me? Do you use VS Code? No. What do you use? Adam. Oh, whoa. This is, yeah. This is even worse. Yeah. I'm going to give you a license anyway, because maybe you want to convert, all right, and make your life better. Maybe you've got a friend that you want to help, all right? It's for any ID, even the IntelliJ. Free, lifetime. What we're going to do now? First, let me be honest with you. It's 8:30. I'm way off my time. So I'm going to give you two options. All right? We need to leave this building before 9. So we need at least 10 minutes. So I can stop this talk right now, summarize everything. Plenty of time to mix, to talk with each other and all this social stuff. And then go home. Or you can give me 10 more minutes and I'll show you something amazing. Who wants to give me 10 more minutes? Something amazing. Man, I got 10 more minutes from the guys here. Oh, you stopped it. Yeah, don't buy hand grenades from Amazon. All right, so what we gonna do now? Let's change your life forever. I'm going to show you something. I'm going to create a function called sum. And this silly function is going to get A and B. And it's going to return A plus B. And it's going to do a lot of heavy calculations in between, because summing two numbers together, it's a hard job. Additionally, it can convert an array to an object or whatever. All right, makes sense? Let's log it. All right, now the question is, I'm going to call sum. I'm going to pass it for 4. All right, so you can see here that it was invoked. Make sense? Make sense? Yeah, of course it is. Let's call sum again and again and again. How many times sum is being invoked? As much as I call her. But wait a second, those are the same arguments. You can call this function 1,000,000 times with the same arguments and you're going to get the same results. So, what's the point? Now let's think about React. Let's think about functional components with React. This is the exact same thing. This is a pure function. You call this function passing in arguments, and if the arguments are the same, you're going to get the same results each and every time. So if I'm going to call this component with the same tags, it's going to return me this exact structure. Make sense? All right. So I'm going to implement it. Technique it's called memoize. I'm going to create a function. I'm going to call this function with cache. And this function, yeah, I can see the typo. And I can reproduce it. This special function is going to accept a function as an argument and going to return another function that you can pass whatever arguments you like. Sounds cool? Yes, it is. And here, I'm going to do a nice trick. I'm going to, I forgot a fat arrow. I'm going to create a cache, and then I'm going to say this. I'm going to take your arguments, let's call it the key, JSON stringify your entire arguments. And then I'm going to check if on the cache I got those arguments as a key. Actually, if I don't have it on the cache, I'm going to save the results of calling the function that you passed with all the arguments. Don't worry, I'm going to walk through this code very slowly. I've got plenty of time. Plenty of time. No, I'm kidding. They let me. They don't like to mix. Want to get the knowledge and go home. All right. Let's walk through this code for a second, all right? You're going to call this function passing your function. I'm going to return you a function. So if you call this function, you got a function back. Cool, all right? I'm going to create an object, just a simple object. And then I'm going to take all the arguments, make a string out of them, so it should be unique, all right? Or the same, I don't know. And then I'm going to use it. I'm going to save it on my object. So right here, I'm going to have something that looks maybe like this. Maybe you pass me A and B, and the result will be whatever A plus B should be, all right? Now, if you've got this key, I'm just going to return you whatever I cached. Makes sense to you. All right, cool. I sense a question, so you can ask, but you won't get any license. All right. Excuse me? All right. Yeah, I know. It's walk through this code, all right, and learn it. Not a big deal. Very well-known technique. Look at Google for memo eyes. I didn't invent this. But wait a second. You know what we just created? We created a high-order component in React. If components are just functions, so if I wrote a function that accepts a function, I created an HOC. Let's try to use it. First, let's try to use it right here. I'm going to create const msum equals to with cache, passing the original sum. All right? And instead of calling sum, I'm going to invoke a better version of sum. I call this function 1, 2, 3, 4, 5 times. How many times it's been invoked? Only once. Cool, so let's take this and go back to our app. And instead of calling tanks, let's wrap tanks. Let's create const better tanks with cache, passing tanks. And right here, instead of calling tanks, we're going to call better tanks. You don't have to rename it, because when you separate those things to different files, you just export default, all right? Like when you use Redux. Make sense? I mean, I'm on the same file. All right. Let's see what's going on. So now we've got a component that cached the results. So if I got it right, when I add tank, makes sense. When I add man, tank is not rendering. Look, add man, no tanks. So what I'm trying to say that probably in your app, you've got a lot of presentational functional component that doesn't need to be re-rendered if you pass the exact same arguments. Cache them. Don't use this implementation. Get it from Lodash. You've got Memoize for free. All right? Let's summarize. I don't want component to re-render with no reason. So, first, break your app into component. It's not just for code maintenance and organization. It's important for performance. Second, if you create a class component, probably you want to extend pure component in most cases, because you don't want the component to re-render if the state and the props are the same. Just remember, it's shallow compare. So if you have this bad practice of creating like a nested state, it won't work, but it's a bad practice anyway. If you've got just a function, because there's absolutely no reason to create a class if you don't use state and you don't need any lifecycle methods, memorize this, cache the results. It's a pure function. You don't need to rerun it again and again and again. How many of you seen this technique for the first time? Give me some feedback so I know. So there is some people here who are already familiar with this. That's good. Just remember, React is just functions, which means that all of those patterns are relevant. Last minute. But a lot of animations. All right. Yeah. So we learned about the framework syntax, render DOM manipulation, React profiling. That's fine. I want to give you another heads up about this community-oriented workshop. So it's going to be the same style. We're going to go deep dive, and it's available for everyone. So if you find it interesting, RSVP. If you like free consulting sessions from us, 500 Tech, go to react.clinic. That's the URL. And we can make an appointment. We can sit for free together with you, go over some code, look at your React app, give you some advice, use it. And just as a reminder, next month in Tel Aviv, there is a ReactNYC conference, which is a bundle of International React Conference and a tour. If you like to hear more details, you can check the website or talk with us. And we've got a discount for you anyway. Thank you very much, first. Second, I asked you to follow me on Twitter, and I got like way more than 2,000. So on ReactNYC anniversary, you're gonna see something that no one has seen before. Take my word for this. Thank you for being part of this community, and keep in touch. Stay in touch. We don't officially got time for questions, but like, how much time does it get to clear the building? 10 minutes? Yeah. If I throw a like hand grenade. Any questions? Yes, please.
Why did adding the key before not prevent re-rendering of existing?
Why adding the key haven't prevent the whole re-render of the list? Because it's a native DOM element. It's not a React component. If it was like an item component, all right, so you'd see when you paint flashing that only one item being rendered and not the entire list. So providing keys for just elements won't make the trick. You use VS Code, take a license. Microsoft hates me. Last questions, please. Ask me questions. You on the back, yeah. No, the one who just did this or whatever, yeah.
What about memory consumption?
What about performance? Because if we're going to cache our entire components, there is a potential of like bloating the memory, of course, all right? So use it with care. I mean, with just a little bit of extra code, you can say if the cache is like, I don't know, if this object's got 5 keys, just clean it up, for example, all right? Don't just cache everything everywhere. Know about this technique, know how to use it for better performance, but use it with care. And use a third party for this, unless you want to learn how to implement a well-optimized memorized function by yourself, all right? You've got one from Lodash, which is great, all right? You use VS Code? Come and grab your license. Guys, thank you very much. I'm going to share this code on GitHub, and I'm going to share the link on the page. I'm going to hang around here and outside the building if you want to talk, ask something or anything else. And see you on the next meetup. All right? You can choose whatever I do.